Hello, everyone. We welcome to our session on what's new in Apache Atlas 1.0. I'm Sarath Subramanian. I'm an Apache Atlas committer and a PMC member. And I work at Hortonworks as a staff software engineer with the data governance and security team. And
Hi, everyone. I'm Apoorv Naik. I'm also an Atlas committer and a PMC. I have been working at Hortonworks for almost 2 years now.
little bit of background about what Apache Atlas is. Atlas is a first-class metadata management and governance framework for Hadoop and other data platforms like cloud, IoT, and mobile system. It enables organizations to effectively and efficiently meet their compliance requirement and ensure integration with the whole data ecosystem. Atlas helps you to build a catalog of all your data assets, classify them, and govern these assets. So some of the main features of Atlas is we have metadata types and instances. We can provide a capability to define new custom types for managing metadata. We can define new metadata for Hive table, Kafka topic, and types can have attributes, and types can also inherit from other types. Type instances are called entities, and it captures metadata, object details, and relationship with other entities. Then we also have classification. Entities can be associated with any number of classification, and classification, you can create new classifications like PII, expires on, or sensitive. And then we have the lineage. As data moves through various processing, Atlas captures the lineage of this data flow. We have an interactive UI to view the lineage of data. Then we also have the search and discovery capability. All the entities in Atlas are indexed. We use a Solr backing indexing store. We also can provide search entities based on attributes, classification, or terms. We also provide a SQL-like interface to search called domain-specific language. Use the mouse. Excuse me. OK. Finally, we have the security and data masking. We have a tight integration with Apache Ranger for security. Ranger enables authorization on data access based on classification associated with entities. A little bit of history around the community. Atlas was started as part of the data governance initiative here at Hortonworks. Organizations like Aetna, JPMC, Merck, Target collaborated with Hortonworks to make Atlas an open metadata and governance platform. We also have folks from IBM, ING, and Comcast working actively with the Atlas community and contributing to it. As of today, we have 37 committers and 33 PMC members. And we started incubation in May 2015. And 2 years later, in June 2017, we graduated to a top-level project. And during incubation, we made 5 releases. And after graduation, we made 4 releases. In June this year, we made our latest release, Atlas 1.0. Here we have a high-level architecture diagram of Atlas. On the left-hand side, blue boxes, you can see all the hooks and bridges we have that integrate with Atlas. They talk to Atlas using the messaging framework backed by Kafka. At the core of Atlas, we have the type system, where we define all our metadata types. And it is backed by a graph database called JanusGraph. And the data inside JanusGraph is internally stored in HBase. We also have search capabilities to search for entities stored in Atlas using classification, terms, or entity attributes, or view lineage data. And all entity operations in Atlas is audited using the audit framework. We also have rich REST APIs to allow flexible access to Atlas services. Then we also have a bridge capability to import metadata into Atlas and export metadata outside Atlas to third-party services. Atlas supports the following hooks and bridges from these data platforms and engines. We have hooks from Hive, HBase, Scoop, Storm, Spark. We also have IBM's information governance catalog tightly integrated with Atlas. It uses Atlas as its backend metadata store. These hooks and bridges provides an asynchronous mechanism for data services to notify Atlas of any changes in their data landscape. And Atlas maintains an up-to-date perspective on where data is stored and its lineage information. The agenda for today's session will be focused mainly on the new and exciting features of Atlas 1.0. This is a major release and a result of more than a year of contribution from the Atlas community. So we have the classification propagation feature. We have the new and improved glossary using relationship. This replaces our business taxonomy feature we had previously. We also have a fine-grained metadata security, which is a much more granular authorization at entity instance level. Then we have new hook for HBase and a new bridge for Kafka. And then we also have various other infrastructure enhancements. The first feature we are going to talk about is about classification propagation. And in Atlas, we already have the capability to associate entities using classification. We can dynamically create new classifications like PII, expires on, or data quality. And each classification can also have attributes. Let's say a data quality classification can have a quality score attribute, and an expiry date can be an attribute for expires on classification. And here I'm going to show you a quick example of how this lineage works in Atlas today. So here we have a Hive table called medical records, and we create a lineage or create a view out of this medical records called the medical records view. And this medical records contain sensitive patient information. Any views or table created out of this medical records table also has a snapshot of this sensitive information. So when you try to associate or tag this medical records Hive table as PHI, meaning that it's protective health information, this tag is not automatically assigned to any tables or views created out of the medical records table. So to solve this, we have the classification propagation feature. Here, when a classification is associated to an entity, it's automatically associated to other related entities. So for the same scenario, you can see that when you assign PHI classification to a medical records Hive table, it is auto-assigned to the view created out of it. If you create a new view out of this medical records view, the PHI tag will be auto-assigned. But not always this propagation behavior is desired. We can control propagation in a couple of ways. When you assign this particular classification to that entity, we provide an option whether you want to propagate this classification or not. And the second way we can control propagation is at the lineage edge level. So clicking on the lineage edge, we can turn on or turn off propagation, or you can block certain propagations to not go through the lineage edge. I'm going to jump to a quick demo about this classification propagation feature. Here we have the Atlas Web UI. On the left-hand side, you can see that we have a tabs for search, where you can search for data assets using type, classification, term, and text. And then we have a tab for classification, where you can search for entities based on tags associated with it or classifications. Then we have a glossary tag. So for this particular demo, I'm going to click on a saved search here, which searches for a HDFS path entity which has the keyword employees. And I'm going to use this entity as an example. So when you click on this entity, it provides a snapshot of all the metadata information about that particular HDFS file. And clicking on the lineage tab, you can see all the lineage information of how this data evolved over its various processing. Here, for an example, we have an employees HDFS file here. And we apply some filter on top of this HDFS file and make it in a much more structured and refined format into another HDFS file called employees. And from this employees HDFS file, I create two new Hive tables. We have an employees Hive table and an employees masked Hive table. And from the employees Hive table, I create three new views based on the demographic of that particular employees. We have UK employees, European employees, and US employees view. So the demo I'm going to show is like when you assign a classification to the source entity at the HDFS file level, it will be automatically propagated to all the children. Let's say it will be auto-assigned to the HDFS file, these two Hive tables, and these three Hive views. Since this employees might contain, entity might contain sensitive information like SSN details or salary details, I'm going to assign a PII classification to the HDFS file here at the source. I'm going to add a classification here, saying PII. And we can mention type as an attribute, mentioning what type of sensitive information it carries. I'm going to say it's employee sensitive information. Like I mentioned previously, we have an option to propagate this classification or not. If you don't want to propagate this tag to any of the children entities, we can uncheck this box. But since we want to propagate this tag along all the tables and views, I'm going to check this and add a classification here. You can see that the classification PI has been added to the entity successfully. I'm going to quickly go to one of the views here and show you that the PI tag has been propagated. Let me go to the European employees Hive table here. You can see that we have a new PI tag here in the propagated classification sections. And also, when you click on the classifications tab, you have all the list of classifications listed here. You can see that PII is a propagated classification listed here. And you can also see that the classification attribute mentioned in the source entity is also propagated here. And we also provide a link called propagated from. So what this link does is it takes you back to the source entity where this classification was originally assigned to. So when you clicked on it, it takes you back to the HDFS file entity where the original PII tag was associated. Similarly, you can update classification attribute in this lineage. Let's say in the HDFS file, I'm going to update a classification attribute. Let's say I'm planning to add more information here, like the kind of sensitive information it carry, like salary and SSN details. And I'm going to update this classification here at the source entity. And I'm going to go to one of the Hive tables, let's say employees here. You can see that the PII classification, which was propagated from the HDFS file, has an updated classification attribute information here. Similarly, we see that we have 4 tags associated to the source entity, and everything got propagated here. Similarly, if you want to delete a particular classification of the source entity, it's automatically reflected to all the children entities as well. So when you delete a reference classification here, when you go to one of the views, let's say UK employees, you see that reference data classification is no longer associated at the propagated classification section. And next thing I'm going to talk about is how you can control this propagation. In the demo scenario I mentioned, we have an HDFS Hive file called employees, and we created 2 Hive tables, employees and employees masked. So we apply some processing from this raw HDFS file and masked all the sensitive information in this employees masked Hive table. So this Hive table does not contain any sensitive information. All the salary details or SSN details are masked with, let's say, ****. So this doesn't make sense to carry PII information anymore. If you want to control propagation at the entity level, we can click on this lineage edge here. It pops up a model saying you can turn on or turn off propagation. Or rather, if you want to drill down a much more granular view, you can see that it has 3 classifications flowing through this lineage edge. We have PII, not public, and data quality classification coming from the HDFS file. So since this classification does not contain sensitive information, I'm going to block PII classification here and update here. It says that the propagation flow has been updated successfully. And when you click on employee mask, you can see that it inherits or propagates other classification from HDFS file, but not PII. And the next thing I want to show you is we introduce a new relationships tab here. So what it does is it provides a relationship view about the different entity association it has. Here you can see we have a Hive table entity at the source, and then we have a DB entity which is associated to it, and then we have 4 columns associated to it, to the Hive table, particular Hive table entity. And we also have a storage descriptor here. And then we have a couple of processes here. This Hive table feeds into 3 new views here. That's what being shown here. And this Hive table was a result of the create external table employees Hive command here. So we capture the entire flow of the lineage in this particular relationship view. And we can also search entities based on classification. Let's say I'm going to search classification, let's say entities based on, I'm going to search for type dataset with classification assigned PII. And when you search on these entities, you can see that in addition to the directly associated PII classification, it also lists all the propagated classification entities as well. So this is how propagation comes into flow. All right. Next, we move on to the glossary feature.
Thanks, Sarath. So I'll be talking briefly about the glossary feature. Prior to Atlas 1.0, we had something called business taxonomy. That was like a tech preview. So now what we have done is we have replaced that with glossary that has much more richer experience and good UI to support the business users to create terms and categorize the terms and have multiple relations between different terms, which are more natural to them. And also you get the capability, we added the capability of assigning terms to specific assets or entities that we call in Atlas. And the categories basically are a way of adding more context to different terms. And then you can also have certain set of hierarchy that you can define. So basically what a hierarchy would enable you to do is have broader scopes or finer scopes for different terms that you choose to categorize. And then last but not the least, we also enhanced our search functionality to use the term. Once you assign a term to an entity, through the basic search, you can use that term to just go and discover the entities that have that specific term. And I'll quickly go over a demo to show how we have enhanced our Atlas UI to support this. So for that, you see that there's a new tab called Glossary. So we just move on to that tab. So by default, you will be launched into the term context view. So what it does is it lists down all the glossaries that are available in Atlas, or rather registered in Atlas, along with the terms that belong to that specific glossary. So right now, we have automotive, finance, insurance, and a bunch of terms that are associated with them. So if you just, by default, the first one is selected. So if you just collapse it, maybe expand the other one, you'll see what other terms we have. And certain features that we've added are, if you want to create a new glossary, you can just click on the plus, and you'll be presented with a modal box asking for certain attributes that are required to create a glossary. So name is one mandatory feature right now, and mandatory attribute, sorry. And the other short description and long description, they are pretty much optional, so you don't really need to them to actually create a glossary. So for now, I won't go through that. The another thing that I'll show is, once you click on a glossary and click on the ellipsis right next to it, you have a small menu that is only in the term context. So it allows you to create a term or delete the glossary. And similarly, for the category, if you go and select if you toggle, so now you'll be in the category context view. What it does is it lists down the glossaries along with any category or the hierarchy that belongs to that glossary. So right now, we don't have anything. That's why it doesn't show anything. So let's just go and create one category. Let's use insurance. So you click on the ellipsis. It says create category. You have a similar modal box with 3 attributes: name, short description, long description. So let's just give it a name, types of risk, demo. So now it says category has been created successfully. And now you see that on the left-hand side, if you expand the glossary, you will have the category listed down there. And if you click on the category ellipsis, it says that you can create a subcategory. That's basically the means how you can go and define an entire hierarchy of categories. And moving on back to the terms view, let's say we also have the ability to search using a term. So if you start typing in the search box, it will narrow down into a term and what glossary it belongs to. So I just search for claim, and it belongs to insurance. So it just shows me that. So when I click on claim, now what I'm presented with is the details about the term. Like what is its short description, long description, what are the classifications associated with that, and what categories it belongs to. So right now, it doesn't belong to any category, so you don't have anything listed down here. Also, if the term is assigned to any of the entity or assets, you will have this entity list populated. So right now, there's something called Hive Data Cost Savings HDFS file. So I think that one has been assigned this term. So you see this in the result set. So now I also talked about categorizing your terms. So how you can do that. One way to do that is if you click on the plus right next to the categories, you are presented with the different categories that are present within Atlas. So right now, since we only have one, let's just go and assign it, categorize that term. And so it's something like that. So if you click on, so every link that you see there, it's navigable. So once you click on the name of the category, it takes you to the category view, and then lists down all the terms. Now, the second way of categorizing terms is to go to the category, select it, and then click on Add Term. So now let's say we add a few things from here. Let's say risk. PDT risk. And all these relations don't have any attributes, so we really don't present any modal box to take user input to have some extra information about the relationship that you are creating. So now I just assign few terms to this category. If you click on either of that, it will take you back to the terms view, and then the term is selected by default. And you see that it belongs to the category type of risk. Now, one thing you can do is you can delete the category, but the terms really don't go away, because the terms belong, like the glossary is a container for the terms, and category is only a way of organizing them. So if you delete a category, it doesn't delete the terms. So you see the morbidity risk, pure risk, they're still there. And let's try deleting one of the terms. So since claim has the assignment to any one single entity, we don't allow the deletion of the term. So you try to delete that. You get an error message saying that the term has been assigned to certain entity, and you cannot delete that. And same restriction applies to a glossary as well. If you try to delete a glossary which has any term assignments to entities, that deletion does not go through. So you'll see the same error. And let's say for automotive, it doesn't have really any assignments to any of the entities. So if we delete that, that should pretty much go away. And now you see it doesn't really exist. And none. It's completely gone. The terms, categories, everything just goes away. And now one more thing that we have done is we have added the ability to relate different terms with each other. So how do you do that? Let's go to risk again. So once you select a term, you have a tab called Related Terms. When you click on that, you're presented with the different types of relationships that we support in Atlas right away. So they are like see also, synonyms, antonyms, preferred to terms, replaced by, and all. What you can do is you can just go ahead, click on the plus, and let's say we select some other term. Once you click on next, here are some attributes that we ask the user about. Like if you want to provide some more context about the relationship, why these terms are related, you can just go ahead and key those in, and then click assign. So now you'll see that once you do the assignment, the see also relationship shows what all terms you have related to that specific risk term. If you click on this one and go to the related, so now it took you back to the morbidity risk. And if you click on related terms, it shows that, OK, it's also related to risk. So this is how we actually enrich your terms and add more, like create more relationships between different terms. And I think the one last thing that we have on the glossary side is search using a term. So if you go back to the search panel, there's a third input text box called search by term, which allows you to look up terms. So as soon as you start typing, you will start getting suggestions about what specific terms you have in Atlas and what you can choose. So let's select this one, click on search, and you get the results about all the entities that have been tagged with this term. And OK, so this is search. And also, you can go ahead and just click Save As if you want to use this search for future references. So let's say claims. OK. And one last thing on this one is, if you click on the term, you see that there's a classification. So by default, any term, if you add a classification to that, and it's assigned to any other entity or asset, the classification is actually propagated by the feature that Sarat just demoed. So if you remove the classification from here, the entity also loses the classification. Now if you click on this entity, go to the details, you won't see any classification. Let's just quickly go and add classification to claims. Let's say insurance. If you click back on the entity detail, go to classification, and you see that it says that the insurance tag has been propagated. And if you click on that, it again takes you back to the source of propagation. And that's pretty much it on the demo side of Glossary. Now I'll hand it over to Sarat to speak about fine-grained metadata security in Atlas.
Thank you, Apur. So the next feature we're going to talk about is the fine-grained metadata security. In previous version of Atlas, we had authorization at a very broad scope. An authenticated user can access any type, add classification, or delete types. In 1.0, what we introduced is called fine-grained metadata authorization. This authorization model enables control of which user or group can perform operation on which types and entities and operations. So we have two authorizer. One, we have the simple authorizer, which is the default authorizer, where you can define authorization policies in a JSON file. And you can assign different privileges to a role, and you can assign these roles to users or groups. And we also have the Ranger authorizer. This authorizer uses Ranger policy for authorization. This policy model supports 3 resource hierarchies to control access based on types, entities, or admin operations. The authorizer by Ranger audits all authorizer into their central audit store. Let's see here for an example. We have an admin user who has access to all types and is allowed all entity operation. Then we have a data steward user who can add, update, or remove classification. Then we have a finance user who can access only Hive table from the finance database entity. And then we have a data quality admin who can access only entities tagged with data quality. I'm going to demo the fine-grained metadata security feature. In this demo, I'm going to use 3 users. We have an admin user. He's like the super root user, and he can perform all CRUD operations on types, entities, and classifications. And he can also import and export entities. And we have an HR user from the human resource department. He can access only entities, Hive table entities from the HRDB database. And then we have a HBase user who can add classifications or remove classifications only related to HBase entities. He's restricted to add classification to any other entities. Here I'm going to log in as an HR user. Like I mentioned previously, the HR user has access only to Hive table entities from the HRDB database. So I'm going to look for Hive table entities in my search. This is going to list all the search results of Hive table entities. And I'm going to add a new column here called database. This shows from which database these entities came from. So this particular HR user has access only to HR database. When he attempts to access any other database, let's say finance here, let's say he's trying to open this tax 2010, he's prompted with an authorization error that the HR user is not authorized to perform this operation. Similarly, and the corresponding record is logged in Ranger. Let me quickly show you in the Ranger interface. OK. Okay, what we'll be seeing here, we will be having a denied permission. Oh,
Access.
okay, sorry, yeah. Okay, you can see a denied permission here. The HR user had denied permission for entity read on that particular entity. And then when he's tried to access any other entity which is authorized to, let's say HR entity, let's say US employees, he's allowed access and able to view all the entities here. And you can see that this particular HR user has been allowed access to read entity and read classification for that particular HR resource. I'm going to log out and log in as a HBase user. So this HBase user can add only classifications for HBase entities. If he attempts to add any classifications for Hive entities, he will be restricted. Let's search for some Hive table here. And when he's, as a HBase user, when he tries to add a classification here, let's say auto insurance and add, he will be prompted with an authorization error here that he can't add a classification. And the corresponding entry is logged in Ranger audit. You can see that the HBase user has been denied permission to do an entity read or entity add classification on that particular resource.
That's an explicit deny right there, right?
Yes. And then when he search for HBase tables, here we have a list of HBase table and which he has authorization to add classification to. Let's say I'm going to add a new classification to this particular table, banking. He's allowed to add classification. It says add classification added to the entity. And in the Ranger audit, you can see that the HBase user has been allowed to add the particular classification for that particular entity. So that's the level of granularity we are talking about. I don't know if you have time. Okay. Moving on. Then we have the new time-bound classification for policies in Ranger. When you associate a classification to an entity, there is an option to provide a validity period. So this validity period is used by Ranger to enforce authorization policies for specified time period mentioned in the validity. So when you, let's say we have an earnings report Hive table here, and when you try to add a classification, let's say not public, you're provided with an option to apply validity period. So when you check on that validity period checkbox, you can mention a start time, end time, and time zone. The idea here is, or the use case here is, when you have an earnings report of an organization and you don't want it to be public until a certain date, let's say Friday of this week, you can tag it as not public and add a validity period starting today till Friday. Till Friday, and Ranger will enforce authorization policy around this validity period. So it won't be public until Friday, and it will be accessible to public after the validity period has expired. Then we also have new hooks for HBase. The HBase hook registered with HBase master as a new coprocessor. On detecting any changes to HBase namespace, column family, or table, the hook updates the metadata in Atlas through Kafka notifications. And currently, only HBase namespace, column family, and table are captured in Atlas hook. We also have a new Kafka bridge. We provide a command line utility called import Kafka shell script. This utility can be used to initialize Apache Atlas with all the topic information in Kafka. And we can also add support to import metadata of specific topic or all topic. And then we have some other platform enhancement.
Yeah, I can. So I think a few of the enhancements that we have done, we have moved from Titan 054 to JanusGraph. Titan 054 hasn't been active for a while now. It's maybe more than a couple of years. And JanusGraph is much more active community. And they are actively developing the graph. And apart from that, we did an extensive rewrite of the DSL. Previously, it was based on Scala parsing, and it was a little bit slower. And now we have moved on to Antler parsing. So the improvement are pretty obvious on the UI, and it's pretty fast now. And the other thing that we have done is all the hooks have been updated to use V2 notifications. So that's like minimal information that you provide, and Atlas can work with that. And it allows up to 50% faster processing times for every single message that comes through Kafka. And apart from that, like you've seen, we have made a lot of significant changes to the web UI. So you can just go ahead, download Atlas, compile that, build, and play around with the UI to get a sense of what all new things you can experience with the Atlas 1.0. I think. And there are other interesting developments are, like one we know of is Apache Spark. They have been trying to integrate with Atlas. So if you have any interest in that, you can follow up with the Spark community to see how that's going. And that's all from our side on the presentation. Time for questions.
Yeah, quick one. So your fine-grained security there, do you guys have any plans to make it less error-prone and make it more restrictive? Like, so the user goes to the interface and they just don't see options they can't use, instead of allowing them to click something and throw up an error.
Context sensitive.
Yeah.
Yeah, I think we can do that.
I can tell you, my users get really frustrated quickly with the fact that they click on something, I got an error
No,
message,
sir.
crap.
Okay.
Okay, I click on something else, another error message, crap.
Right.
They get frustrated.
Yeah.
Okay.
The default behavior here is like we want to deny to all users and allow only to certain users. That's why the other set of users is getting error. But yeah, we can work on improving that. Yes?
You mentioned about the high views, right? Because we're using 0.8 version of the high Atlas layer. But when I tried to see the lineage, I was not able to see the lineage with 0.8. Is it something, a new feature that was added back on Atlas 1.0?
Yes. Hive lineage, did we?
I think lineage was pretty much there from 0.8.
Talk only about the views.
Or I'm not aware of that.
I've seen on your very first slide where it talks about
This one?
the extreme right, you mentioned that you have lineage now captured for the high views as well.
Yes. So the default data type here is Hive table still. But if you look at the process that is coming from, you can see like a create view name. That's so you know that it's a view that's coming out of tab. We don't have an explicit type for a Hive view. It's still a Hive table. If
Maybe we can take it offline.
Yeah.
Because when I try to, let's say if I have a sequence that comes from a Hive table, then I have a view in between. And now if I want to create another persistent Hive table, I can't track the lineage and when it that one. Because Hive view is breaking and I was not able to see it.
I see.
Atlas there is I think 0.7 lineage, but if you have done an import to get the metadata into Atlas, then you may not see the lineage. If Atlas hook intercepted the view creation operation, then it will report the lineage correctly. We can talk about the more details on it.
Sure. Any other questions?
Is there any metastore level hook at this point? Because we can't control all the clients to put the hook on the client side. So is there any server level hook which we can put?
Currently, we don't have any server level hooks.
So which client you are referring to? Hive? Yeah, so we create table using Spark, Hive, everything. So Atlas hook runs in Hive server 2, so which is different from Metastore, but it's Hive server 2 on the server side. We don't recommend any hook on the client side. So we have clients using both Metastore and Hive server 2. Okay. So it's very difficult asking the customers to migrate everyone to Hive server 2. Right. So this question comes up frequently. Maybe we can take it as one of the community items.
Sure.
So is there any plan to create a HDFS hook as well?
We have planned to hook HDFS hook, but the thing is like it is always very resource intensive. Any changes in HDFS file will be continuously being processed in Atlas. So we want to do in a much more granular way. Only directories which users are interested, we want to drag metadata out of it. We have that line item in our mind. We'll be attending to it.
One of the challenges we are facing right now is we have sensitive data sets on HDFS and on Spark, right? And it is consumed by Spark, Hive, tables. But it is okay to model these Hive tables on Atlas, but actually we are not securing the data set, given that the data set, the HDFS data set is not modeled in Atlas properly.
Yes.
And it's a challenge to keep it sync also.
Mm-hmm.
So maybe we can take that up.
Yeah, sure. We can discuss that offline, yeah. All right. Any other questions? Yeah, we have improved V2 style API. We have improved in Atlas 08 version itself. We have improved most of our APIs to use the new structure. So that has resulted in faster processing and much more structured format of the objects defined in Atlas. All right. Thank you, guys.
Thank you all for coming.
So we welcome contributors to the Atlas community. If you have any questions, feel free to access the wiki site, or if you have any Atlas-related specifications, you can mail our dev list or user list. Thank you, guys. Thanks for listening.
Thanks, everyone.